Okey, dengan tanpa berlengah masa, saya persilakan Profesor Abdul Karim Alias untuk menyampaikan webinar pada pagi ini untuk sharing kepada semua akademik dan juga mungkin kalau ada non-akademik yang akan join. Okey, dipersilakan Prof.
Terima kasih Puan Zailani. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Selamat sejahtera, selamat pagi kepada semua sahabat-sahabat ahli akademik Unit 10. Terima kasih kepada yang dapat hadir pada pagi ini. Saya faham semuanya sibuk dengan kuliah dan juga urusan-urusan akademik. So feel free to if you have to leave, it's okay. Saya akan kongsikan juga nanti link untuk access this presentation ya pada penghujung nanti. Jadi pada pagi ini mungkin dia sampai 2 jam ke mungkin 1 jam lebih sikit saja mungkin. Saya nak kongsi tajuk ini on curriculum ya. Tapi saya nak maklumkan awal-awal saya bukanlah pakar curriculum ya, bukan pakar curriculum, bukan pakar curriculum design. Hanya untuk berkongsi my take, my thoughts, my ideas, or how I envision curriculum in the context of so-called Industry 4.0, Fourth Industrial Revolution, ataupun dalam tajuk ini saya menggunakan istilah VUCA. VUCA ya, VUCA which is an acronym stand for the world that is volatile. V, U is uncertainty. C, complexity, and A, ambiguity. And this actually describe very well the kind of world we are living now, and the kind of world we are facing in the next few years. Very dynamic, ever-changing, very unpredictable. That's the VUCA world. So in the context of this ever-changing world, very dynamic, unpredictable, how does our academic program respond to it? How do we adapt to it so that our academic program in the context, especially the context of engineering program at Unit 10, will be relevant? And more importantly, how do we differentiate our academic program, our engineering program, with our neighbor next door, which is our neighbor next door is what? IUKL. And with the engineering program in other higher institution in Malaysia. So if we just look at the Malaysia context, there are many universities are offering engineering program. And what is unique about engineering program at Unit 10? How do we differentiate? How do we stand out? And how do we make our engineering program or other academic program for that matters be a preferred one when the students, when the prospective students are considering to apply every year, to UPU and so on, or to apply to the university, would they look at Unit 10 engineering program as one of the options? And not only one of the many options, but one of the main options. So I would like to use the session this morning to kind of have some kind of exchange of views and opinions on how do we move forward in terms of redesigning our curriculum So then the title today, this morning, Reimagining. So we want to reimagine, rethink, re-engineering, reimagining engineering curriculum for the VUCA world. So for those from non-engineering program, don't worry, because it's basically applicable across the board. Yeah. So let's think about this together. Now, I have a video that I have created using AI. Okay, so I want to share this video, which basically to convey the message or the idea about how do we transform, how do we adapt to the new world in terms of redesigning or reimagining our curriculum. So let's watch this together. I'm not very sure whether you can hear the audio. It depends on the setup, but let's play the video.
Open your minds to the revolution.
It's only 1.04 minute, 1 minute's video, yeah?
Of engineering education. The future is here and it's digital. Forget outdated textbooks and monotonous lectures. Welcome to a world where learning is interactive, dynamic, and tailored to your needs. Imagine complex engineering concepts simplified with digital tools. Picture yourself mastering intricate designs through immersive virtual reality. Envision learning at your own pace with AI-driven personalized lessons that adapt to your strengths and weaknesses. This is not a distant dream, but the reality of today's innovative educational landscape. Digital transformation in teaching and learning is not just a trend, but a necessity. It's time to reset engineering education, exploit the power of digital transformation to make education more engaging, efficient, and effective. We are on the precipice of a new era in education, so gear up for the journey and embrace the change. The future of engineering education is digital, and it's here to stay. The revolution has begun. Are you ready?
So this is a video. You can find the rest of the video in my channel, YouTube channel. Okay, I want to say something about this video. This video, I created this. I produced this video using AI application, using only one text prompt, and this is exactly the prompt or the instruction that I give to the application, and then after that, the rest will be done within a few seconds, less than 1 minute, to create a video. So the instruction is create a 1 minute YouTube video about engineering education reset, exploiting digital transformation in teaching and learning. Fast-paced, energetic. So I just tell the application the type of video, the mood. Yeah, the mood is fast-paced, energetic. Make a compelling case for transforming engineering education. Make the background music calm but inspiring. So this is the world of AI now, the type of AI application and what it can do. Just by using this text instruction or prompt, it can put together, pull all the relevant video clips, put them together cohesively to form a storyline, put the music, put the caption, the voiceover, everything. So the reason why I'm showing this video, not only to show about basically the idea of reimagining the engineering curriculum, but the video itself is to illustrate how the disruptive technologies, including AI now, can be leveraged, or how we can harness the power of AI to transform the way we teach, the way students learn, and to deliver the best learning experience, impactful, memorable learning experience to the students. That's basically the message that I want to share from this video, and also to set the scene or the context of our topic this morning. Now, because of the world of VUCA, the world that is ever changing, there's also a changing demand of engineering education. So this is how we would respond to it. So engineering education around the world now is evolving rapidly, and disruptive technologies are playing a vital role in transforming it. So this is actually driven by the technology as well. So to ensure that the next generation of engineers that Unit 10 produced is well equipped to tackle the challenges of the future, therefore, the program designer, the curriculum designer, and those who deliver that in the classroom or online, we need to embrace these technologies, the disruptive technologies, and modernize our curriculum and delivery methods. We cannot just be content, complacent, stay, status quo, and just continuing doing what we do every year, every semesters, year in, year out. No changes at all, or maybe incremental only, and we don't see the impact so much. And yet, we expect people or students will come in numbers to apply to come to our program, or the quality of graduates will improve every year, and our graduates would have high demand in the industry. But how do we meet that kind of demand if we don't change the way we do things? Albert Einstein said, it's insanity. It is insanity doing the same thing again and again and expect different results. So, my dear colleagues, sahabat-sahabat semua, let's take a closer look at the changing landscape of engineering education and explore how disruptive technologies are shaping this new world. The new world, which is a VUCA world. And what's our role in it? And how do we play our role? How do we position ourselves? How do we position our program? How do we position our university, Unit 10 now? Because Unit 10, pusaka di hatiku, ya. All right. Now, VUCA. By now, I would expect many people would have heard and understand and can talk about it. What is VUCA? So VUCA basically stands for volatility, uncertainty, complexity, ambiguity. So the world that is volatile, something that is volatile is always kind of moving in the flux, so-called fluid, ever-changing, like the Brownian motion. The particles in the Brownian motion, kinetically moving. It doesn't stay. It's not stagnant. It keep moving. It keep changing. So how do we live in a world that is volatile? Uncertain. We cannot predict. Tomorrow will be different from today. AI, for example, has been advancing so fast. Complexity, the kind of problems we are dealing now, is getting more and more complex. The engineering problem they are facing now become more and more complex. And yet, how do we teach in the classroom? Maybe still using the same old problems, kind of traditional kind of problems. Of course, to teach the fundamental, we can start with a simple problem, but the problem is ever increasing in the complexity, and how do we expose our students to this complex problem? How do we teach them to solve a more complex problem? Because they are going to face, when they go out, more complex problem, engineering problem, even the kind of problem that we face in life become even more complex. Ambiguous. It's very similar to uncertain. Ambiguous is something that is you cannot really tell the difference between this and that. There's always some kind of gray area. It's not just black and white. You cannot really draw a line to separate, between the two entities, for example. So it's kind of gray, a shade of gray, kind of, so to speak. So dealing with this kind of world, what we need more is we need to have a clear vision. For example, when we design our engineering program, or when we redesign or reimagining when we do curriculum review, I don't think we want to use the same approach that we have done previously when we do curriculum review. Adding new courses, taking out some courses, shifting from compulsory or trust courses to elective. These are very traditional way of doing things, and we keep doing it again and again. What we need to do now is to have a clear vision of what the world looks like in the VUCA world. And how do we now redesign and reimagining our curriculum beyond adding new courses, taking out some courses, and so on. Beyond that, understanding of the world, of the VUCA world, understanding the demand, the new kind of skill set, the new technologies, the new kind of job that we do not know what kind of job will be needed next month, next year, in the next 5 years. So we need to prepare our graduates that would be able to adapt to the new skills, the new kind of demand of skill set, the new job, and so on. Not to prepare them for a specific job or specific skill set. Clarity of purpose, clarity in everything that we do, and agility. Agility means, agile, meaning that we are able to change, to move, to transform as the demand, as the new demand, come. Flexibility, agility, adaptability, come what may in the future. The second round of pandemic, for example, second round of lockdown, come what may, we are ever ready to face the challenge because we are agile, we are adaptable. We have that kind of growth mindset that always ready to grow, to learn new things, to learn, unlearn, relearn, and so on. George Couros, one of the educators, prominent educators, he said this: change will come our way. We cannot, it's inevitable. We cannot avoid it. We cannot escape. We cannot run away. Change will come our way. We have to face it heads on. So, but we can go through it. We have the option whether we go through it, we face it heads on, or we grow through it. If you just go through it, you just go with emotion, well, maybe nothing much happen. But if you choose to grow with the challenge, with the change, you take it, you take the challenge, you face it, then you solve the problem, you adapt to it, adopt and adapt. So you will end up growing. Yeah, that's the outcome. We grow when we seek out solutions rather than let obstacles hinder us. This is kind of mindset that we need to have. We need to develop in ourselves, in our students, in our administrators, in our leadership. Always, when we face with the challenges, we look at the challenges as an opportunity for us to learn and to grow. We develop the skill or new skill set to deal with a new challenge. So when we develop something new, we grow. We grow in our skill set, we become more skillful, we have a new kind of tool set, we have a new kind of mindset. It doesn't stop us in our track. but it actually led us to grow and to become better, to improve the system and so on. I hope I can get this message across to everyone, because this is what we need now for our institution now to go to the next level. Now, since the pandemic, everyone is kind of now become more familiar with the online learning, online teaching. But now, I think we need to go beyond that. But are we prepared? So if we look at what's happening, overseas, you see like Cambridge and so on, they are looking now beyond online learning. They are looking into the different things, how they can reimagine the curriculum, how they can bring the better learning experience for the students. So researchers launched a live experiment to imagine the post-pandemic university. What about us in Malaysia? What about us at UNITEN? We ought to ask these questions truthfully and sincerely, because always won't open new doors. Doing things, in the old kind of ways. It won't open new doors. It won't open new opportunities. So let's ask ourselves, how much have teaching and learning practices changed? How much our teaching and learning practices have changed after the pandemic? After being exposed to the new ways of doing things, online learning, synchronous, asynchronous, have we changed much? I would love to be invited to your classroom and see how you do things. Maybe I can give some input there. Or is it still status quo? We revert back to pre-pandemic era, doing the same things what we did before the pandemic. So status quo, nothing much change. We revert back to the old ways of doing things, because people say old habits die hard. Susah to remove the so-called old habits, old ways of doing things. So we revert back, because things kind of post-normal, become like a new normal now. So, or more of the same. Not only we revert back, but more of the same thing. This we have to answer. I want to share this quote from Sir William Crowe. For those people from engineering, especially from civil engineering, maybe they know this person, one of the most notable English civil engineers of the 20th century. And he said this about engineering education. The well-being of the world largely depends upon the work of the engineer, because he's an engineer. Maybe the medical doctors will say the same thing as well. The other people from different discipline will say the same thing as well. Teachers will say the same thing. But for engineer, he said, the well-being of the world largely depends upon the work of the engineer. There is a great future and unlimited scope for the profession. New works of all kinds are and will be required in every country. So when we take this quote, try to understand it, basically what he said here, the unlimited scope for the engineers, because the world need engineers to build, to create, to design things. So the kind of engineering program and engineering education that we deliver now, or we design, should evolve with time, should evolve with the new demands, technologies, and so on. So as we face the threat of machines replacing humans, in an increasing number of tasks, the world will depend on future-focused engineers. By extension, future-focused computer scientists, future-focused social scientists, social scholars, economists, future-focused economists, future-focused everything. Just substitute that. Not only engineers, yeah, that can adapt to new technologies and thrive. Not only adapt, not only survive, as I always say, but flourish and thrive amid Industry 4.0 workforces. So I wish everyone can have this kind of mindset. We don't have an option now. We have to transform the way we do things. We have to do things differently. We have to look at our curriculum and go beyond normal or usual, ordinary curriculum review. We have to study what's the new demand out there, the new kind of engineers, the new kind of computer specialists, computer scientists, computer engineers, the new kind of social scientists, social scholars. What is the new kind? It is defined by what? By the demand of the VUCA world, driven by the technologies, disruptive technologies, AI, and so on. Industry, so-called Industry 4.0, or the fourth industrial revolutions. So, my dear colleagues and friends, there is an urgency to reimagine, to redesign the way we craft and deliver our education, so that not only we remain relevant, that's not good enough, but we want to be the preferred choice. Our engineering program, our academic program will be the preferred choice, so that people will come in numbers. They would want to come to UNITEN because they know the program is unique. The offerings of the academic programs are not only unique, but when they go out, the graduate will have great value. That would be in high demand. The employability would be no issue. So these are kind of the reason why we want our program to be the preferred choice and relevant, because we are different. UNITEN is different. UNITEN is bold. We are bold. Bold stand for our strategic plan. But are we bold enough? These are the questions, the critical, thought-provoking, honest questions that we should ask ourselves all the time. All the time. Otherwise, we will get ourselves busy day to day, going to lecture, giving lecture, preparing for the exam, for the test, marking the exam, grading the papers, finish one semester, then we start the cycle again. Think about it. Yeah, think about it. So, curriculum, ada apa dia? Someone nak ask questions or share something ke? Ada ya? Okay, now let's look at why do we want to do, why we want to reimagine the curriculum transformation. So again, when I want to embark, on something, Amy, can you?
Azrina ada soalan ke?
Itulah. Ada mungkin dia ter-unmute ke?
Okay. Mungkin ter-unmute.
Yeah. Can you? Okay. Now, curriculum transformation. Why? why we want to talk about reimagining the curriculum. Because our future depends on better leaders with good values. Think about our graduate, engineering graduate, or our graduates, Unit 10 graduate that will go out and work or become leaders. We want them to become leaders with good values, smarter innovators, and more informed global citizens. They are not only citizens of Malaysia, but citizens of global. So we want them to have a world view, world perspective. We want them to become inventors, innovators. We want them to become the trailblazers. We want them to become someone who will, come up with great ideas, would lead the country and so on. So we are preparing the next generation of exceptional, lifelong and life-wide learners to work together in solving the most complex challenges of our time. So we want to prepare our graduates to become a lifelong and life-wide learners, because we don't want them to stop learning the moment they left the university. When the moment they leave the university, then they stop learning. No, we want to cultivate and nurture the mindset that they want to learn throughout their life. Yeah. So let's ponder on these questions. I'm not going to ask you to answer now, but this is something that we want to think about it together. How do we design a curriculum that is not more of the same? Benda yang sama tapi buat lebih lagi. Or the same old flavor. How do we design a curriculum that will prepare our graduates not for specific skill set? Because skill sets are changing. The VUCA world, the nature of VUCA world is like that, ever changing. So if we prepare our graduate for a specific skill set, that skill set may not be relevant tomorrow. Or specific job, because in the fourth industrial revolution or industry 4.0, we are not able to predict the kind of new jobs required. But we want to design a curriculum for the jobs that do not exist yet. How do we do that? How do we design the curriculum that will inculcate valuable, transferable skills? This is keyword here. Transferable skills. They can adapt themselves. They can develop a new skill because they have the basic fundamental skill. Very strong. That will make our graduates flexible, agile, and adaptable. This is what we want when we reimagine our curriculum in our mind now. We will prepare our graduates to be flexible, agile, and adaptable so that when they end up anywhere, they will rise and flourish. We throw them anywhere, they will survive and they will thrive and they will flourish. This is what we want. And this is what and how Unit 10 graduates can differentiate themselves from other universities graduates. And this is how we create demand. This is how we create demand in our graduates, because our graduates have great values in terms of skill, in terms of knowledge, in terms of other attributes or traits. Yeah. How do we connect students' learning with the real world problem that they will face at the workplace? Are we happy? Are we content with the kind of simplistic problem that we get them to do, to solve, to work on in the class, in the assignment? Are we content with that? Or do we need to do more? Bring the authentic kind of problem, authentic assessment, real world problem beyond the textbook? How do we do that? We have to think about it. we have to find the ways and mechanism so that our students now, you know, that's why I like the 2U, 2I, 3U, 1I kind of things, because we can design actually kind of work-based learning to expose them and let them apply what they have learned in the classroom to the real world. This is part of the thing that we need to think about when we reimagine our curriculum. Oops. Next question, how do we design a curriculum that will develop the intellectual capacity and maturity of the students, and at the same time they are equipped with the core competency with high level of proficiency? So let's look at the question again very fast. Let's ponder. 1, 2 question here, 3 questions, 4 questions, 5 questions. I want to ask everyone here, not only for engineering people, everyone, when we do curriculum review, do we ask this kind of questions? Do we ask these fundamental questions to guide us to do the curriculum review? Ada tak? Ataupun kita terus jump in and kita kata okay, kita rasa because of this development and ini, we need to add this course. Macam tu. Ataupun based on the report from external reviewer for our program, these are the comment, these are the suggestion. So let's address that. So to address that suggestion, we add this course. I think that's the most common way of doing things, of doing the curriculum review based on the external curriculum report, or maybe just looking at the trends. Maybe other universities, the same program at other universities, they start to offer that program. Then we said, oh, maybe we should also offer the same program. I like to get some views here. What do you think is a practice that curriculum review that has been practiced here at Unit 10, at least, if you have been involved? Any input from anyone here? How many participants we have? Amy?
We have around 30 macam tu.
13.
30.
Yeah. So okay, mungkin saya kena switch ke, sebab saya tak nampak chat. Cuba I like to, if anyone can unmute the microphone. I saw Puan Zarina tadi ada. Puan Zarina, you like to share something about the curriculum review? How do we approach curriculum review? Anyone here like to share? Yeah, Dr. Renduga, you like to share something on the curriculum review? How do we approach? Have you involved in any exercise curriculum review?
Yeah, Prof.
Yeah.
Involved in for the undergraduate,
Mm-hmm.
and then also for the masters in electrical engineering. So I think in terms of the review, we do the benchmarking. Okay, with the other universities, what they actually having in their universities, and then after that, I look at also at the local and at international other universities, and then see the relevancy of the topics and how best it is being conducted in terms of like a blended learning rather than the conventional way of teaching. So
And I think the other processes we follow like the standard what the Pekeliling says lah, all the procedures. But I think being innovative is something is crucial now. So like for master's program also we try to bring in like AI so that it is relevant with the current requirement and the situation. So not just looking at the topics, but also to see how flexible we can actually have this with the situation of our students, whether they are working or they are like undergraduate students, how they are and how proficient they can be lah, and how they can adapt. Because I think it's quite demanding. It is very demanding on their side as well nowadays.
Well, yeah.
Yeah. Yeah.
Thank you very much. What you mentioned, those are quite common approach. Benchmarking is very common. Then reports from external examiner, this is another one. But I'm curious how much actually engagement with, for example, alumni of the program. These alumni that have been working for many years. How extensive, how serious and extensive this engagement with the alumni of the program that already is working in the same discipline, to get a feedback from them, because now they are in the real world, they are working, as a professional, their input to improve the program, the relevancy of the program. So I think that part is always very, very much lacking, because of sometimes difficult to get in touch with the alumni and so on. But that input from alumni that is currently working in the same area or discipline as professional would be very, very useful as input to consider to improve the curriculum, to redesign and reimagine the curriculum. That's one. Then the engagement with industry through the EAC, for example, for engineering, through the industry representative that we have, and wider engagement with the industry, because we want to know the real demand out there, not just a perception, or not just because of the trend. Then we cannot imagine only the demand, but we perceive the demand, but the real demand is not there or not there yet. So these are all the things that we need to really consider if we are very serious in reimagine or rethinking the curriculum, so that our curriculum stand out from the other program offered by similar program offered by other universities. Any more views or from the audience? Your views on curriculum review? What are the different things we can do? How we can approach this curriculum review in different way? Any more ideas? If not, I will continue. Okay, now I just want to mention about this. Our Ministry of Higher Education, they have done a lot of work and published a lot of documents. Unfortunately, this nice document, a result of many hours of work by people from universities especially, end up on the shelf, and sometimes even people at the ministry also not aware of the existence of the document, let alone the academics staff, academics lecturers, leaders at the university. So they are not aware of the existence of this document. But is this, for example, this one, Framework, Malaysia Education Framework 4.0. Only those people involved in writing the documents, they are very much aware, of course. But beyond that, only a small circle of people aware. So sometimes a lot of wastage of time doing all this nice document. But if we look at this document, Framework 4.0, look at the future-ready curriculum. So when we talk about reimagining our curriculum, no, nowadays the buzzword is future-ready curriculum, future-proof curriculum, future-ready graduates, future-proof graduates. So everything here have been kind of spelled out very clearly. So when we do curriculum review, do we look at this kind of documents? Do we look at some of the recommendation of the models, the framework, everything that would guide us or help us in designing the new curriculum? So I'm not going to elaborate this, but the documents are there, the frameworks are there, the models are there. In fact, specifically on the engineering, I've seen the documents on the engineering framework for engineering education, something like that. So these are the kind of resources that we need to get our hand on of, so that we can use this to help us. And look at this one. When we talk about fluid and organic curriculum structure, this is actually from the same document. You can download the PDF actually. Just Google Malaysia Higher Education Framework 4.0. You can get the whole PDF. And inside this, I take this diagram, looking at the three main pillars or backbones of curriculum: structure, delivery, assessment. And then each one, the structure, you can see the details here. And all these things, we need to capture this. And when we do a proper kind of workshop, extensive workshop of curriculum review, all these things need to be laid out very clearly to our kind of brain before we start the brainstorming and so on. That will become the basis of the new curriculum or the reimagining curriculum. We look at the structure, we look at the delivery, we look at the assessment, we look at all these small details of this. So we need to consider all this when we do curriculum review. So when we talk about reimagining curriculum or reimagining engineering education and curriculum, the future of engineering education should be, these are the characteristics: flexible, adaptive, and student-centric. And I think now we need to consider this, breaking the silos of traditional discipline. Now we still have EE, electronic engineering, electrical, civil engineering, chemical engineering, mechanical engineering, and so on. Silos. But in the last like 10 years or so, we start to see these silos have been kind of broken down, but they're still very limited. For example, program like mechatronic, where we have mechanical engineering and EE, electrical electronic. So we have mechatronic. I remember in the early days in USM where I was also involved in this thing. So they talk about mechatronic, then they say, oh, okay, this basically we combine some elements of mechanical, electrical, electronic, and so on. And true enough, the demand is there. The demand is there. What about now? We look at all this discipline program across the board. Now we should talk about integration now. Multidisciplinary, transdisciplinary, and so on. By using the design thinking approach and Apple's think different philosophy, we can reimagine engineering education to better serve both students and the industry. Serve the students meaning that we want to create value for them. The value proposition is about creating value for them when they go out in terms of employability, in terms of our engineering graduates stand out among the engineering graduates from other universities. So think about evolution now. Traditional curriculum versus the modern curriculum. What is the modern part? The modern. So the evolution of engineering education has brought upon about significant changes in the curriculum. We have moved from discipline-based to interdisciplinary courses, static subjects, rigid structure to modular and flexible courses. That's why we talk about micro-credential now. Micro-credential is about making the big program into modular. So we can fit in the modules to form a complete curriculum, and we can take out certain module and offer it as a standalone program, standalone certificate program, and so on. That's the beauty of modular. Because just like an engine, our engine is designed as a modular. So if one part break down, it doesn't affect the other parts. We can just simply change that module, that part. We buy the spare part, we change only that part. We don't have to overhaul the whole engine. That's the concept of modular. Think about our curriculum. If we design it as a modular, so when we do the revision, we don't have to revise the whole program. We can revise only a certain modules, especially the module that is very fast, change very fast. Flexible, modular and flexible courses, and theory heavy, content heavy, theory heavy program to real world application and problem based learning. Can we teach the engineering program only problem based? Maybe that's very extreme, but maybe can we now move to like 50% of the program is problem based, real world application. It's something that we can throw the ideas and think about it. Of course, it's not going to be easy. Nothing is easy, but we have to ask this question: can it be done? Is it really necessary? Is there a demand? Then and so on. Those questions that I asked just now. So let's explore the ways in which modern curriculum differs from traditional curriculum. So this is why we want to use a term responsive curriculum, dynamic, fluid curriculum. Responsive means that it is response to the ever-changing demand of the engineering graduates. Floating curriculum. I want to say something about this because not many people are aware about this. MQA is not a stumbling block. MQA actually facilitates. For example, it already allows at least 30% of so-called non-prescribed content or courses in a particular program to cater for the emerging body of knowledge in a particular discipline. Meaning that the power is bestowed to the Senate. Senate can make the decision. It doesn't have to go to MQA for that 30% portion of the curriculum. So when we talk about floating or fluid curriculum, the university or the Senate of the university and the program owner has been empowered to do whatever they like, to do whatever they see fits within this 30%. Okay. Of course, for engineering programs, still within the EAC kind of scope, but there is a 30% as far as MQA is concerned. Do whatever you see fits for your program to make your program more relevant, to create demands for your program so that your program stand out. Your program can be, differentiated from other program and so on. 30% have been empowered. But we don't probably take this opportunity to to the fullest. This is where I want to say here, the 30% where we can use this to create, to kind of creative enrichment of the program. So we have to be very creative now to enrich that part, the 30% that allowed, empowered to us, so that we can create very innovative kind of engineering program that would stand out from other engineering program. Okay, so what would be the ideal curriculum design? Is there such thing as ideal curriculum design? Think about this. A curriculum that is a mile wide and an inch deep. Mile wide and an inch deep, meaning that is very broad. So we try to stuff in, put courses, everything, hoping that the students would use this knowledge and skill when they go out. So the 4 years, 8 semesters, everything that we feel needed in the program outcome. So very broad, but not very deep. Do we want a curriculum like this, or a curriculum like this? An inch deep, an inch wide, very narrow, more specialized, but a mile deep, very specialized. So, or we have to strike a balance. We have to find a balance. These are all the things that we need to look at the whole curriculum, not just looking at individual courses and so on. So models of curriculum integration. So we say that we want to break the silos now. We want to do more kind of integrated curriculum. Why integrated? Because life is integrated. Why isn't learning? Okay, so this diagram just kind of to illustrate how this fluid and organic curriculum can be made possible. Convergence of discipline. And I'm not only talking about within the curriculum, within the engineering program, civil, EE, mechanical, computing, chemical engineering, and so on. No, not only within engineering, but other program as well. How do we converge this discipline, break the silos, and create a unique program? So, something like joint cluster, hybrid technical program, where we have the elements of arts, we have the elements of the new things like data science and so on. Put them together as one full curriculum. I think for engineering, it's quite hard to do this for undergraduate program. But for master's level program, especially for by coursework, I think it is very possible. So think of this more for the master's program. Undergraduate, because of the requirement of the EAC and so on, is probably more difficult. This is one example that I did for USM. When I was asked to kind of come up with some ideas for integration. So I proposed a few. This one only one example. Bachelor, undergraduate level. But I was told by engineering colleagues, it's hard to do this at bachelor because of the constraint imposed by the requirement of EAC and so on. So perhaps we can consider this for master's level. But just for the purpose of illustration, you can see here, 4 years, year 1, year 2, year 3. So we have here a combination of computer science and electronic engineering. These two programs, computer science and electronic engineering. So first year, maybe a combination of modules and perhaps ideally we want to design this as a modular program. Yeah, so we have modules, computer science, electronic engineering. Of course, it will carry certain credits, of course. Then on the third year, they start to specialize more kind of modules coming from computer science but in each of this module, this is where the integration comes in. Yeah, for example, smart green technology. So the integration of computer science here, the integration of computer and electrical engineering here, and the same thing for each of these modules. Then end up with so-called group project or capstone kind of project, where they will combine everything, and this is more like ideally more like a authentic industry-based real-world problem here, so that the student will experience the real thing from this program. So this is one example. Another example here of integration, integrating disruptive technologies in the curriculum. Well, I'm talking here more not integration of the different program, but more of integrating the disruptive technologies in the curriculum. Integrating disruptive technologies can revolutionize how we educate our engineers. Artificial intelligence can shape personalized learning path. Extended reality, XR, can simulate complex engineering scenarios. And IoT, Internet of Things, can provide real-time data collection and analysis in practical projects. Let's see how we can integrate these technologies into various curriculum areas. Oh, I think I put this slide wrongly, the position. This slide should come first, because I want to illustrate the example of breaking the silos, integrating the different kind of engineering program and non-engineering program as well. So this is one example. Just now I give one example of the computer science plus EE. This one, a glimpse of the future, case study, digital ecosystem and environmental engineering. Example of maybe master's program with this name, digital ecosystem and environmental engineering. Maybe this is something that we can consider for Unit 10. This one I actually kind of created or coined the name of this program, combining digital, this is from EE, but in environmental engineering. Especially we are the champion of, we are energy university. We want to champion SDG. So this is a kind of program, combining two different programs. This one probably from civil, maybe. Yeah, this one from EE. And we call it DEEE, Master's Program, Digital Ecosystem and Environmental Engineering. So we can equip with all these technologies needed to deliver this program. Yeah. Another one, Sustainable System and Technologies Engineering. How we can merge environmental engineering with the digital. So, so the transformation in terms of how we transform in terms of delivery now. Just now is curriculum, then the delivery. So this is where we can leverage, we can harness the so-called disruptive technologies. Because disruptive technologies are not only transforming the curriculum in engineering education, but are also revolutionizing the delivery methods. We have moved from classroom lectures to virtual and augmented reality session. We want to go beyond textbook assignment to AI-driven simulation and localized learning to global collaboration. Instead of creating a collaborative project group work within students within the Unit 10, I've seen UPM, my colleague, Dr. Wan Zahanis, create a project, group project for her students that involve several partner universities in Malaysia, plus universities in Canada, I think. So this is a brilliant example of going global. Our classroom now become a global classroom. Who who dares to take this challenge to create a project work, group work, that involve not only students working together, with their friends in the classroom at Unit 10, but involving other universities. It is logistically difficult to do this, but if you want to go beyond, you are bold enough, dare enough to sacrifice, put some effort, sacrifice your time, energy, and so on to give the best learning experience to the students. That's very transformative. But don't start asking questions like, what's in it for me lah? If you do this, yeah, then you'll never get started, and when you start to ask that kind of questions. So I just want to say here, when we talk about disruptive technologies, actually we are now at the brink of, we are at the tipping point for artificial intelligence. We are experiencing AI in real time now with generative AI, ChatGPT and whatnot. Yeah. So now, how do we harness the power of disruptive technologies? Let these disruptive technologies become the new frontier of engineering education or our academic program. So these disruptive technologies are mainly defined by AI and machine learning, extended reality, XR, AR and VR, Internet of Things, blockchain, and so on. And these technologies are not just a buzzword anymore. They are transforming the way we approach engineering challenges, and it's crucial that we adapt to these changes. It's no longer an option. It's no longer a question of, should I use it or not? No. It's a question of when. When are we going to use this in our curriculum? So we want to reinvent the learning experience of our student together with the development, advancement in technology. So the role of disruptive technologies, they can reinvent the way we deliver educational experiences. Artificial intelligence can track and adapt to student performance. So this adaptive learning concept, adaptive learning platform, XR, extended reality, can create immersive and interactive learning. And IoT can provide real-time data collection and analysis. So we make use of the data analytics. We make use of learning analytics to help us to personalize learning. It's impossible to do personalized learning without data, without learning analytics. Very difficult, especially if you are dealing with big classroom, because we don't have data. We don't have data to track the behavior of the students, everything about the students' activities, engagement, and so on. So we cannot do a necessary intervention at the appropriate time. So let's see how these technologies can reinvent. Example. So with all these disruptive technologies, the bottom line is, the objective is, we want to create immersive learning experience by using immersive learning technologies that we can integrate with traditional education methods, providing a more realistic and stimulating environment for growth. It incorporates digital media, simulation, and other interactive tools to create immersive experience for learners. So virtual reality, VR, augmented reality, AR, can help us to create immersive learning. Remember at one time, there's a game, Pokemon game, remember? Wow, the craze of Pokemon a few years ago. Wow, sampai macam-macam, crazy things lah at that time. Berlaku accident dan sebagainya, because people were crazy playing this game. This is perhaps an excellent example of immersive gaming. People are basically engrossed and immersed in their world playing this Pokemon game. By extension, can we create an immersive classroom where students really immerse and engross learning in that classroom? They don't want to, they want to be there. They love to be there. They don't want to go to other classes because they are so immersed in the environment. They are so engrossed. Can we create such kind of class? So in engineering, we have lab simulation. Instead of traditional lab, students can use VR to simulate experiment, machinery operation, or even large-scale infrastructural project. Virtual field trips, very difficult to go to the factory, to go to the site, because it's very noisy. Sometimes the factory or the industry are not willing to take a big number of group of students. Or sometimes the issue of safety. If you go to the oil apa dipanggil tu? Oil drilling platform, it is not really easy, or logistic wise not difficult, not easy. But we can use a virtual field trips where students can see things, can learn something, can experiment within a safe environment. Collaborative design, students across the globe can collaborate in a shared virtual space, designing and testing engineering solution together. It is happening now at some universities. But where are we? Are we using some form of this? So this is the example. If you go to internet, if you Google this one, IXR Labs, you can see many examples of the kind of turnkey, something that we can buy from off the shelf. If we have the money to bring all this virtual reality and learning environment to Unit 10, but we have to invest. How this article, if you Google, is there, how the metaverse will promote immersive learning in higher education. Read about it. You see, this one, IXR Labs, YK Lab for engineering, enhanced retention, enhanced comprehension, enhanced industry knowledge, enhanced research mindset. Benefits. So you can see here all these XR, AR things, doing simulation, everything. Benefits: accelerate learning and reduce industry curriculum gap, better equip the real world application, attract more admission and increase footfall, improve college ranking, high level of industry knowledge leads to better placement, be recognized as an innovation, excellent and latest technology leader. Over. Okay. Salah klik. Another example, you see, all these are XR or AR or VR kind of thing, extended reality, excavating tunnel using tunnel boring machine in VR. So students now can really go and see the parts, they can experiment, they can learn everything in a safe environment. Yeah. Virtual field trips, save time and money with inexpensive virtual industrial visit. Okay. This is example of YouTube. You can find on YouTube from IXR Lab as well. You can see how they deploy the XR facilities. This one is bridge construction, site walkthrough in virtual reality. I want to play the video. Exploring an oil refinery walkthrough in virtual reality. VR for equipment, experiment and exploration. Artificial intelligence, personalized. So when it comes to AI, it can really help to personalize learning through adaptive content, automated tutors, and predictive analysis by using learning analytics. So adaptive content, AI algorithm can track a student's progress and adapt content to cater to their strengths and weaknesses. Automated tutors for basic queries and clarifications. AI-powered chatbots or virtual tutors can provide instant answers, reducing the load on human instructors. Predictive analysis. AI can analyze student performance to predict and preemptively address potential areas of struggle and dropout risk. So this is kind of learning intervention that we can do based on the data captured, based on the learning analytics that can tell us what's going on in one dashboard, can tell us everything. The power of learning analytics of data. IoT, how it can help us in engineering education. Smart lab, equip lab with sensors to gather data, allowing students to conduct experiments and analyze real-time data remotely. Interactive classroom, IoT devices can create an interactive learning environment where physical objects in the classroom respond to digital inputs, aiding in understanding complex engineering concepts. I have seen this actually when I visited the Smart Campus project in University of Melbourne. Really very impressive. They showed us the dashboard. They showed us all the facilities to support using IoT, mainly using IoT to collect data in real time. So it's really very impressive, very impressive. And that was in 2018 when I visited the University of Melbourne to look at their Smart Campus project. 2018. Now we are 2013. Sorry, 2023. Where are we now? Blockchain, transparent and secure credentialing. Blockchain is actually technology behind cryptocurrency, but now it has expanded in terms of the application, mainly a way to authenticate. So we can use this in digital badge as part of micro credential, digital credential. We call it digital badge, digital credentialing. Gamification. There are a lot of opportunities now by using XR, VR, AR, augmented reality. I mentioned about Pokemon game just now, immersive game. So how do we bring this into engineering education? When we say game or gamification, it's not only for kids, for children, no. We can design this for also, adult games, but for learning, okay? 3D printing, hands-on prototyping. So we can bring this into our curriculum, into our lab, to bring the learning experience, to get the students to apply their skill, their knowledge into designing, because the engineer do design. Engineers are supposed to be good in designing. Remote lab and cloud computing. So how do we do this as part of our curriculum delivery? How do we integrate this into our curriculum? Flipped classroom, yeah. I don't want to say much about flipped classroom because this is just a mode that we can now have the best of both worlds, face-to-face and online. We are supposed to now be very good at using online. Or are we? But assuming now we are good now with online, now we can redesign our classroom using a flipped classroom concept in a more meaningful, more effective way. So I think I will skip this one. So finally, to end my presentation, to wrap up my presentation, I just want to say that we need to navigate the new landscape of education in the world of VUCA, in the VUCA world. We need to face the challenges and provide solutions. Navigating the new landscape of engineering education is not without its challenges. Yes, It's going to be many challenges, but we cannot shy away from that. We have to face all the challenges heads on. Ensuring accessibility to advanced technologies and keeping up with the rapid technological advancement can be difficult. We need to adopt maybe hybrid models. We need to have more working in partnerships, collaboratively, and to adopt subsidies. Yeah, maybe we need to subsidize our students to ensure that all students have access to these technologies. Unit 10 as a whole, I think, need to put an investment here to bring all these things, to our classroom, to our lab, and train our lecturers to use all this. Simultaneously, we need a modular curriculum. I really strongly advocate for a modular curriculum because of the flexibility it provides us. Continuous training, this is where CAFEL come in. I think this year, maybe hopefully next year, working together with our new CPD system, HR, and so on, we need to roll out the CPD system. We need to be more serious now in continuous professional development. Instead of having 20, 30 people in program like this, we need to have more. We need to have all the 400 lecturers to be exposed to these new ideas, new challenges, new way of doing things, new way of teaching. And bring more, we need more engagement with industry to stay updated with the latest trends and developments. So call to action, start exploring disruptive technologies in your own teaching practice. Consider integrating new technologies into your curriculum to better engage students and prepare them for the changing landscape of engineering. Connect with the colleagues and other educators. Don't just work within the boundary of Unit 10. To share knowledge and best practices for implementing new technologies in engineering education. UTM is very strong in engineering education. I'm sure many of you knows Professor Khairia, yeah, but now she's in US now. She's basically reside in US now, but we can invite her online, yeah. Advocate for more resources and support for educators looking to embrace disruptive technologies in their teaching. Encourage your students to explore new technologies and tools to enhance their learning and prepare them for the future of engineering. So the road ahead, as a conclusion, engineering education is ever evolving and disruptive technologies are shaping the landscape of the profession. Embracing change as the new constant, we can prepare our future engineers for the challenges of tomorrow. Decisively adapting to the disruption requires modernized curriculum, cutting-edge delivery methods, and partnership with the industry. This new landscape offers an excitingly limitless potential for engineers trained to navigate it. So if you like to have access to this presentation, this is the QR code. You can scan and you can have access to this presentation if you're interested to browse, to learn, to look at it again after my sharing. So with that, thank you very much everyone for staying on and listen to this sharing. Maybe I would like to open to Q&A. Or maybe I can pass over to Puan Lani or Dr. Jahana or Amy. Yeah. And we can open to dialogue, discussion, sharing thoughts. Anything? Anything from the chat?
Okay. Thank you, Prof, for the very interesting sharing on this curriculum for engineering, how we can adapt with the latest technology so that our students get the utmost benefit and quality education from us. So I think we open question to the audience here. We have so many, ada beberapa orang lecturers daripada engineering. Maybe you would like to respond to what we have heard from Prof this morning, especially on engineering.
Siapa from engineering here? From in this list?
Ramai juga saya nampak daripada engineering. Kita ada Prof Hisham, Dr. Hasril pun ada, Mr. Liao.
Your take maybe, your thoughts on what I've shared just now.
Yeah, without any excuse lah, I think we need to adapt with the latest disruptive technology in our educations. For engineering, like you said, virtual visit to the field, and then using the VR technology that will enhance the students' learning lah. Cumanya technology, maybe we have the challenges here to create or to develop the systems lah, to be used in class. Yeah, maybe we are still lacking of the skill in developing such programs or systems.
Tapi itulah kalau kita nak ambil shortcut, jump the curve lah, jumping the curve. We just need money lah to invest. So those virtual system tadi tu, banyak, ada few good companies are actually selling those. So but it's expensive lah. So I think if we collectively as an institution very determined to go towards this direction, then I think we need to put up a very strong proposal for this to the top management and top management to the board. I think we need some substantial investment on this so that we can save time to develop the system, so we can just buy the system. Then all we need now is to train our staff, our lecturers to use the system, and then we can customize it, personalize it according to the needs, using their own cost, for their own cost. So now we can start using it already in our curriculum. It can happen very fast if we are willing to invest. But what I've shared just now in terms of transforming or reimagining the curriculum is not limited to technology. Technology is part of the delivery part, but more so of the curriculum. The curriculum itself, how do we go beyond what we have now? So this is where, one of the key point that I want to reiterate again is about breaking the silos. How do we maybe for master's program lah. Breaking the silos is one, meaning that we offer integrated kind of master's level program, perhaps a new program. And then the second one, apart from a integrated program to break the silos, the second key point is how do we redesign our curriculum to be modular? Because once we have the program in a modular format, we can do curriculum review very fast, because we don't have to look at the whole program, but we can look at the modular unit, the module that we need to kind of revise, update, or kind of add new things and so on. So the module can also easily be replaced if necessary with the new modules, rather than for the whole course of the whole program. So there are three key things here. One is the curriculum. For the curriculum, we are looking at breaking the silos, coming up with a new kind of integrated kind of program, master's level. Second one is about designing the curriculum content into more modular format. And the third thing is actually for the delivery, where we look at how we can harness or leverage the disruptive digital technologies. So those are the three things, key takeaways that I hope clear to everyone here.
Prof, Dr. Chua Yao Long, Dr. Chua is here. Kalau boleh, probably Dr. Chua can have your live question to Prof. Dia ada dah type dekat chat. Tapi kalau
Okay.
Dr. Chua ada, then maybe Dr. Chua can speak up.
I can see the chat. Maybe, okay, as you mentioned, engineering education syllabus is seriously constrained with a restriction by ESC, correct? Are there any other ways or approaches that we engineering educators can take up to ensure creative teaching without really going against ESC? I think there's a lot can be done, plenty of room to maneuver, Dr. Chua, even within the undergraduate curriculum. I think ESC is not really a constraint or a stumbling block. As long as we adhere to their main requirements, but I don't think they dictate on the delivery. More maybe on the curriculum and the outcome, they look at the outcome, but they don't really dictate. Same like MQA, they don't dictate, they don't control the way we deliver the program. So the way we deliver is very much up to us. We are empowered to do whatever we feel, we think fit. So this is where the creativity of our lecturers are very important. The skill of our lecturers are important in using all the various strategies, technologies, AI, whatnot. So we are given that freedom to be creative, to be innovative in the way we deliver. But as far as curriculum is concerned for undergraduate, maybe there are some constraints there, but I think still plenty of room we can maneuver. But I believe master's level program where you can have a lot of rooms to be creative there and to offer innovative, creative program by combining like certain program together, integration, yeah, can happen there. Okay, Dr. Chua, do you have any additional thoughts or comment or respond to my response? Yeah, I can see Dr. Chua. Okay, okay. Also, breaking the silo. I appreciate your definition of breaking the silos. Engineers in the 21st century cannot be working in silos and also solo. Yeah, I always stress that we educators are the product of previous century where we were taught to work in silos. So what is your advice? My advice to educators, well, very obvious, we have to work collaboratively. I think the nature of the world nowadays is collaborative, multidisciplinary, transdisciplinary. I suppose only those who have experience, have a real life experience, working together with partners, with colleagues from other areas, you can see it will kind of open up a lot of opportunities because you start to see how you can work together, how the different areas actually can work together and benefits and synergize together. Because that's the nature of of the technology now. One piece of device like our smartphone is a combination of many different engineering innovation behind it. Mechanical, material science, material technology, electrical, so many, chemical, and so on. Yeah. So it's integration of different fields. That's why we need to break the silos. If we cannot do that much in the undergraduate level, why not Unit 10 can come up now with integrated engineering program. Wow, I can see example that I've shown just now is only one or two. If we look at the SDG 17 SDG, Sustainable Development Goal, from there, we can try to kind of link with the engineering program that we have now. And I think I actually asked Dr. Jana recently how we can engage all the College of Engineering to have like a 2 days workshop so that we can have this kind of brainstorming and so on. The way forward, Hala Tuju engineering program, the Unit 10. I can facilitate that workshop, but I want everyone to come on board. Bring, we have to put our mind, our heart, our thinking to come up with something different. Not only different, but really can create demand for the industry, for people who, to come and take the program. Anything else?
Thank you, Prof. Okay,
yes.
So I really appreciate your especially the second part regarding the breaking the silos, because I totally agree with your point that we as an engineer or engineering educator should not just work within engineering itself. We have to work with others, colleagues from education, from the humanities, from the social science, because okay, I have a degree and master's in engineering, but my PhD is actually from the humanities. So when I took up the PhD, it really opened up my mind and perspective that I cannot have it in engineering. That's why I see all these things, and I found out that our engineering education systems are actually there's a lot of flaw there. There's a lot of issues there. I can see that. That's why I raised up the questions how we as an engineering educator have to come up with the creative teaching so that the students are really attracted to come to STEM education. It doesn't have to be engineering, as long as it's STEM. I'm okay with it. So that's why I said that we cannot just shock sendiri in engineering. No. We have to really go into other fields and contribute and work together with that. That is my point of view. And if we just shock sendiri in engineering, we are sorry to say we are going to be left out very soon.
Thank you, Dr. Cho. I think that's a very good input from you, and very good point as well. You see, just like when we look at the screen now, every one of you is in the circle, right? And that's a good actually illustration to show that most of the time we are actually staying in our own bubble. I always use that metaphor, we are staying in our own bubble, our own so-called comfort zone. So we rarely or seldom stretch the bubble, let alone step out from the bubble. So stretching the bubble is probably the first step, meaning that, for example, when we collaborate, not only collaborating with our other colleagues from other programs within Unit 10 boundary, but across the institution in Malaysia. And also maybe now the next step, when we stretch the bubble even more, we work with colleagues across the institution, across the countries beyond Malaysia. So we are, the point is, we are there enough to take the first step to stretch the bubble step by step. Start by working with one colleague from different program, then with 2, 3, 4 within Unit 10. Then go to work together collaboratively with our colleagues from engineering program at other universities, or maybe from other programs that would add value to our basic degree program. Maybe from Institute of Biotechnology in UPM, for example. All these things, I think, if we don't sit down and start thinking about it and envision. There is a kind of envisioning, yeah, the exercise to envision, to do the foresight, strategic foresight for our engineering program. Looking 5-10 years ahead, looking at the trends, looking at the statistic and data that is readily available on how engineering education is moving forward together or in parallel with the development and advancement in Industry 4.0 and whatnot. We need to do this exercise, consciously. Otherwise, we will continue doing the same thing again and again, and nothing change. And yet we hope people will come to do our engineering program. People will come to Unit 10. And we hope that our alumni, when they graduate, they will speak of all the good things about engineering program at Unit 10. Would they? What kind of added value that they have got? So these are kind of very frank, straightforward, honest questions that may not sounds easy to our ear. It's not a nice music to our ear, but something that we have to really talk about in all the honesty.
I totally agree with you, sir. I totally agree, because that 4 years of PhD in from UPSI, when I did my PhD in UPSI, and it really opened up my mind about, because coming from the technical and engineering to go into something that is in social science, humanity based, to see how actually the pedagogy of learning, how teaching and learning is, and how we are doing it in engineering is really, sorry to say, horrible. We are doing in a way that we do not do it in the right way. That's why I'm changing my ways of teaching and I'm learning all these things. I want to learn all these things. Even in terms of module development itself is also a very in-depth process, Okay, module development is not just creating your PowerPoint slides. It's not just like your teaching and learning, your assessments. Oh my God! The moment I went through that, oh wow, this is the whole process of module development, teaching and learning, the assessments, how you do the. Oh my God, this is a total eye opener for.
Yeah, well, that's what CAFEL.
Eye opener for me, honestly, and it's really changing my perspective towards engineering education, the way I see it. I've been in engineering education for like over 20 years, but the past 4-5 years in my PhD work in UPSI really opened up my whole wider perspective, totally.
Well, at least it's a good start that you are aware and you understand that there is so much more that we need to learn in order to become an effective engineering educators. That's good, but you wouldn't actually be thinking about it if you don't expose yourself and put yourself in the position to learn about other things beyond the courses that you teach, right? So that desire to learn more, to explore more, so that you can enrich your teaching, enrich the learning experience of the students by doing that. And also, if you can read journals related to engineering education, because I believe you have a journal of engineering education or similar, because in many discipline, for example, chemistry, they have journal of chemical education. In physics, they have journal of physics education. That kind of journal usually will publish articles related to the best practice of innovation and activity of sharing experience. So they will publish, of course, there's some evidence that their methods work or their innovation work. So I would encourage everyone here, not only engineering, to find a journal, something in your area, journal of something education. These are the kind of journal. In my area, it's called Journal of Food Science Education. So if I read this journal, I will see, wow, you know, there are many different ideas and innovation that done by my colleagues around the world. Then this give me a lot of ideas that I can try out in my own classroom. Okay, so hopefully CAFEL will basically play this role to help expose our staff, our academic staff, with the new teaching methods, innovation. But we want people to come. If people don't come, then they would not be exposed to all these ideas. All right, so I think that's very good. Anything else from others before I like this kind of dialogue and exchange of ideas, because the moment we start to talk and we express our ideas, our feelings, our thoughts, share our experience, share our aspiration, that is the time when people start to come together and talk about how to move the institution together collectively to the next level. If we don't have this kind of obsession, people will continue doing things, sitting in their room, and get busy with day-to-day work, go by the flow, and end up with busy. But productivity-wise, maybe not so much. And in terms of progress, we will find out at the end of the year we don't progress very much. This is what the famous writer, English writer Ernest. He's also a poet, Ernest Hemingway. I like to quote him. He said, "Don't mistake motion for action." Don't mistake motion for action, meaning that it's like you are running on the treadmill, you know, you're running faster and faster, berlari setempat, but then you realize that you're not going anywhere. You're not making progress in terms of distance, of course, in terms of stamina, maybe. All right. Don't mistake motion for action. All right, so Puan Lani, I think probably that's about all. Kita nampak Dr. Jana ada di sini. Ya, Dr. Jana.
Maaf, Alhamdulillah. Sorry for coming in late. I just had a couple of meetings in between. So still manage on the last two lines. Motion is mistaken as action. Don't mistaken that. Yeah.
For action, yeah.
Okay, so I believe the time is 11:21. So from 30 sahabats together, perhaps from 9:30 in the morning. Do you have anyone last burning question? So I understand that this is regarding engineering education, yeah? Reimagining engineering curriculum. So I was made to understand that there was one chat. Have Prof answered this? The one by Dr. Chua?
Dah.
Yeah. So this is interesting. Yeah. So when we think of it, sometimes when we are starting to teach technical kind of subjects, etc., that we tend to just follow the textbook, and then we are so afraid to becoming creative. So I understand. So what's your take on this, Prof. Karim? So, I mean, not trying to overdoing it. Is there a simple rule that we can do when it comes to being creative in our classroom? Still not jumping out from that particular syllabus. Perhaps you have answered this, but maybe you can put it as a summary.
I answered it. So I think, as I mentioned, the constraint by EAC is not should not actually stop us from, because I think there's still a lot of room for maneuver to apply our creativity and our innovation, especially in terms of delivery, because EAC or MQA, for that matter, they don't control basically how we do things. They look at the outcome. Basically, it's outcome based. So meaning that if you want to go to Penang from here, You can choose to go by highway, or you can choose to go take a flight. So it doesn't really matter. You'll end up, inshallah, safely in Penang. So the same thing like outcome based, basically the philosophy behind it. Do whatever you think fit, but this is where we can be very innovative, very creative. But the bottom line is students would achieve the outcome in terms of the skill, knowledge, and so on. But I think sometimes we are too bogged down and focused on achieving the outcome. We forget about the experience of the students. So we are too much driven by getting things done at the end of the semester.
Yeah. True.
Habiskan
Finish the
syllabus.
syllabus, preparing the final examination. It's all taking up all our energy. Yeah.
Betul. Kita too bogged down and too driven nak habiskan syllabus dan sebagainya. Tak boleh blame, memang itulah kita kena buat. But by doing that, okay, at the end of the day, after the exam, kita kata, okay, we report outcomes achieved successfully.
Yes.
Yeah.
All COs are met.
Have we ever care to ask our students, please give me your honest feedback apart from formal apa tu survey yang dia orang kena buat tu, kan? Please, you go and talk and have conversation with the students. Please tell me frankly, and I've done that. So that's why I'm saying this, because I've done that. I did that. So I panggil apa ni, the student datang to my class, to my room, itu okay, and I asked for the top student, I asked the not so top student, kata please tell me frankly, I won't, penalize you, or no, please tell me frankly, what do you think? And true enough, many of them said, oh, we appreciate your effort and so on, blah blah blah, but we still prefer you just give lecture. Ada yang kata macam tu.
Yeah.
So meaning that while we are too focused on getting things done, but we should also ask the students their feedback as whatever we have done is good enough for them, whether they have learned, and most importantly, their experience, something hopefully positive, so that imagine throughout 4 years, throughout X number of courses, throughout the X number of lecturers they have experienced and went through, when they go out, we want them to go out taking away the best memorable experience, positive experience, so that now they become the alumni, become the ambassador.
Yes.
Otherwise, they will just become an alumni, and they can't wait to forget about the bad in fact, experience with alumni. And they can't wait to say negative things about Unit 10.
Yes.
We don't want that.
That explains why not many alumni are interested in coming to Unit 10.
Not Unit 10, but also I say the same thing at USM and other universities when they said, why our alumni don't come back to us, don't support us, and so on. Then I ask these questions. What make them remember USM when I said to USM, and what make them to loving USM, and to be able to say USM dulu, ini, dan selamanya, to make them to say that Unit 10 pusaka apa di hatiku,
Pusaka sayang.
Pusaka sayang. What make them to really say that from their heart, from the bottom of their heart? If they can do that, if they can say that, they will become the volunteer ambassador for Unit 10. Tapi siapa yang, macam mana benda tu boleh terjadi? We have to play our role. We have to look at our curriculum. We have to look at our delivery. We have to look at our skill set. We have to look at the infrastructure, everything we need to. And we need to start that with having this kind of dialogue.
Betul. Dialogue? Webinar ke dialogue, Prof?
Dialogue lah. Webinar dialogue.
more interactive.
Yeah, but people are
Betul-betul.
not willing to talk. That's the thing.
Yeah. Okay. Thank you so much, Prof, for your insights, yeah, especially on reimagining all this curriculum, especially engineering curriculum. So, so I believe this is not the end for Prof Karim's series of webinars. And thank you so much to Prof Karim for spending his time, always being there.
My pleasure.
Yes, okay. And he's ever ready to
Ever
move
ready.
any kind of topic. Yes, ever ready. Macam bateri tu. Uh, untuk menyebar luas ilmu yang banyak. So sama-samalah kita dengar, lepas tu kita hadam, lepas tu kita boleh fikirkan dan juga kongsikan jugalah across our Unit 10 academics. Dan ia tidak terhenti begitu saja. Selepas ini kita akan adakan beberapa siri yang mungkin menepati our competency framework. Mungkin Prof Karim dah ceritakan. Okay, yang mana bagaimana untuk menggalakkan kehadiran pensyarah-pensyarah yang mengikuti kursus-kursus begini. So kami akan mengadakan macam package-package ya, bukan a la carte menu, tapi kita ada mengikut beginner, kita ada intermediate, kita ada advanced level. So tunggu-tunggu kan, competency framework akan disiapkan tak lama lagi dan akan dijangkakan menantikan majlis peluncuran competency framework depan. Entah, saya pun tak faham lah, Prof. Pelancaran ke peluncuran? Okay, saya gunakan apa yang sekarang ni. So, kita akan adakan competency framework launching in the very beginning of next year, perhaps. Okay, terima kasih so much, Prof Karim. Thank you everyone for having us. Dan jangan lupa untuk mengisi attendance dan juga evaluation untuk webinar ini. Jumpa nanti dalam webinar akan datang. Terima kasih. Assalamualaikum. Have a nice day.
Baguslah DJ ni.
Saya
Thank you, Prof.
Okay, thank you, everyone.
Okay, thank you.
Waalaikumsalam. Thank you, Prof. Dr. Jihana.
Terima kasih.
Thank you, Prof. Thank you all.
Terima kasih, Prof.
Thank you, Prof. Thank you, Dr. Jihana. Thank you, Kafel.